Okay, so it's Monday night CAD time, and that means we are gonna do some FreeCAD designs. I hope you watched the previous one. We made a swinger bobbin for carp fishing, and it worked really well. I even used it and caught a couple of fish on it. Not carp, but at least we know it works. So for today's episode, I was thinking about letting you guys decide what to do, but since we don't have anyone here yet, I do have a couple of ideas. We can do like a what was it called, boilie, the thing that you smash the boilies with. We can do a tackle box. What else can we do? Yeah, I have my profile, I think, what was it called, lure dryer turner. Yeah, so I had this design, but it didn't work really well and it wasn't parametric, so if I wanted to change anything, it might break. Plus I did it in Fusion 360, so I was thinking also maybe we can redo this using FreeCAD. So let's see, what else can we do? What was it called? The boilie cutter. Huh, interesting, but this is already done. So we have the lure turner, we have the tackle box. Now the boilie crusher thing will be nice because we can use the what was that called, the lattice workbench to make arrays, basically lattice 2 workbench, but we can even use it in the tackle box. Let's start a new design. Whoops, what happened? Unnamed, yeah, okay. I think I'm gonna do the tackle box because someone actually requested it. And by the way, if you guys have some ideas for the Monday night CAD stream, if you can join my Discord server and add them in the project ideas section. Like for example, here's an easy idea, just a tackle box. Maybe we can do that. So tackle box, what did they mean exactly? Did they mean like these or the lure box? I think they meant something like this, like an organizer, right? That's actually nice. You can put your rigs here, some stuff here. Now this is super complicated, of course. We're not gonna do that in like an hour or two, but can do something similar. Let's turn off the music. So yeah, I guess let's do a tackle box. As usual, the first thing that I would do is create a spreadsheet. And here I can define all the parameters that I need in my design. So there are multiple ways to do this. We can define the full width and height of our tackle box, and then maybe auto calculate the width and height of these sections, for example. Or we can define these sections and then the tackle box will be, or the width and height will be automatically calculated. Yeah, let's do that. Let's say section 1, section 2, and then the rig holder, basically. So let's do that. Okay, so for that I think we need multiple spreadsheets. So let's name this one, rename it. Let's call this one section 1. Then let's create another spreadsheet. Call it section 2. Let's call this one the rig. Can we have space? Let's do it like that. Rig holder. Then we can have a common one later. So section 1. I think we need to define the depth. Yeah, we need a common one for sure. Or let's call it the tackle box. So for section 1, we need to define the width and the height. So basically here we're talking about no, not width and height. Let's call it width and length, because height would mean this. Let's call this length. So width and length, and then section 2, I think it should have the same width, right? Or it will be very weird. Yeah, let's say they must have the same width, but the length will change. I don't think we need 2 spreadsheets for these. Let's delete them. So we can do these under tackle box. So let's say section 1 or section width, which is common between both of them, and then we have section 1 length, and then let's just copy it, section 2 length. Okay, so the section width, let's just put any number for now, 150. Length, let's say 200. Let's say this is 300 or whatever. Now these are big numbers, but we'll fix them later. That's the beauty of parametric design. We can change them whenever we want. Let me fix the camera. Yeah, this should be better. Okay, and then we have the rig holder. In the rig holder, it must have the same length of these two. So let's just give it a width. But we need a spreadsheet for the rig holder because it contains other stuff. So let's leave it here for now. Length, or sorry, width, because the length will be the same. Will be auto-calculated basically. And for the tackle box, we need the thickness of the tackle box, maybe the outside thickness, and there's the thickness of these separators. We can have them all be the same parameter. So for simplicity, let's just say thickness 3 mils, for example. What else do we need to define for now? We're gonna define more stuff later, but for now, I think these are enough to create the basic shape. Oh wait, we need the radius. Yeah, let's call this the border radius. Let's say it's 10. Okay, so now we need to give an alias to these. So these are just rows and columns. They're not going to do anything until we give them an alias here. So this number is going to be the section width. I'm just going to copy the name and put it in the alias. thickness, border radius. Now, these should have minimum and maximum values, but for the sake of time, I'm not gonna add them. Maybe at the end we can do that, but for now, just leave it like that. And let's start with the basic shape. By the way, if you have any questions or anything, you can let me know. Just write a message and I'll try to answer all your questions. Okay, wait, did we create a body? No. Okay, so first we need to create a body. This is gonna be called, let's call it the box, and then we'll create the lid later. So we need to create a sketch on the XY plane. And do we need to have it a center rectangle or start it like that? Which one is going to be easier? I think let's just go with this. Let's go with that. So, oh wait, we need to calculate. So we need the total. This has to be calculated. So total width. So what is the total width and the total height? How do we calculate these? So for the total height, or let's call this length again, total length. So for the total length, it's gonna be, we're gonna start with some thickness here. Then we have the height of section 1, then another thickness, then the height of section 2, and then another thickness. So we have 3 thicknesses multiplied by 3, and then we add the 2 lengths together. So the total length is going to be equal to thickness multiplied by 3 plus section 1 length, yeah, plus section, this is not a plus, section 2 length. Okay, so this is our total length. So now if I change this to 100, it's gonna automatically change here. Total width is going to be, again, we have 1 thickness, 2, 3, and the width of the section plus the width of the rig holder. So this is going to be the, again, thickness multiplied by 3 plus section widths plus, okay, so here we need to get a value from the other spreadsheet. So there are multiple ways to do that. Usually when you create a spreadsheet, they are numbered, but this can get confusing. So we can actually get it by its name if we do double, what are these called? These things. Rig holder is what we want, yeah. And then, no, not column width. What was it called? This sometimes happens. Oh, we haven't added an alias for it yet. So let's say it's 60. And let's add an alias width. So here it's width. Did it work? 219. Let's change this to 70. 229. It's working. So total width, give it an alias, and now we can go back to our sketch. Let's define the horizontal line as this is going to be our tackle box dot total width. Okay. And now we need to constrain the vertical distance on this line to tackle box dot total length. Okay, and we still have to do the border radius. So how do we do that? We have a fillet command, create fillet. And all we have to do is click this line, then this line, and repeat this step multiple times. Now, if you notice, the color is changing. It was green because it was fully constrained. Now it's, oh, we lost our, it's fine. We're gonna re-add them. That is fine. Yeah, so basically we lost our constraints, and that's why it's currently under constraint. So let's re-add our constraints. So by selecting this point right here, which is on this line, and the farthest point here, we can re-add our width. So formula editor, tackle box dot total width. Okay. So the reason it was lost was because we had points here earlier, but when we added the fillet, these points are gone. So now we need to select the farthest points here, and this is going to be our tackle box dot total length. Okay, we are still under constraint because these can still move, and yeah, and now since we lost the point that was here, this is moving freely, so we need to redo the constraint. So if I select this point and this line, we can add a constraint point into object. Come on, don't do that. Yeah, okay, that's fine, just delete them all. Yeah, and now this point and wait, yeah, this point and this line, again, point onto object. Okay, so now we pinned down here. We need to constrain the radius of all of these. First of all, let's make them equal. So I selected everything and let's make them equal. Now they are all the same radius, and let's pick one of them. Let's do this one down here, and we can constrain radius. The value for this is going to be tackle box dot border radius. Okay, so now if we go back to our spreadsheet, let's change this to 25, for example. It's gonna update. Okay, so now with our sketch selected, we can pad up, and yeah, we probably need some parameters for this. So what else do we need? We need to know the height, right? But we already know the thickness, so let's define this section height, and then we can add to it the thickness. We get our total height. So section height, let's say it's 65 or something, and then the total height is going to be equal to our section height plus thickness. So this is the total height. Now we can select the sketch and click pad. This will extrude upwards. Hopefully it's upwards. Let's see, if we reverse it, it's gonna go down. Yeah, it's upwards. And we need to extrude by tackle box dot total height. Okay, so what do we need to do next? Let's start by creating these sections right here. So So if you notice, if we look at this section here, it has a radius, but if we look at this corner and this corner and this one, there is no radius. So we need to take that into consideration when we're making this. So let's do it. To do this, I want to draw on this face right here, but because of the topological naming issue, I'm not gonna like select the face and create a sketch on it. So to keep this parametric, I'm going to create a datum plane. So let me show the origin. This is our origin, this is the XY plane. If I select the XY plane and create a datum plane, I can now this datum plane is attached to the XY plane, but I can move it up in the Z direction. And how much do I need to move it up? That's easy. It's our rig holder dot total height. No, not rig holder, it's tackle box dot total height. The same height we used to create the pad. So now if I hide the origin, select the datum plane, I can hide it, I just want to select it. So select the datum plane and create a sketch. So this sketch will be exactly at the top. And it's also parametric. So if I go to tackle box and made this 80, it will still be at the top. So now we need to draw the cutout that we need here for section 1. And to do that, let's create a rectangle. So we know that, okay, first, before we do anything, so we don't have to redo it again, let's create a fillet here. Okay, because we want this fillet. So we know that the distance between this point and this line, we already know that it's the tackle box dot thickness. This is how much material we want between everything basically. And then we can do the same here. So between this and this is a vertical distance of tackle box dot thickness. Now we can still move these. So let's constrain this line to be our not spreadsheet, no, it's tackle box dot section width, because we already know the width. So now we can only move up, and let's constrain that also. This is gonna be the tackle box dot section 1 length. This is section 1. Okay, did we set it to this value? Section 1 length is 100, section 1 width is 150. Let me see, we need to reduce the width, or let's just do it as it is now. We'll change it later, it should be fine. Now we need to constrain the radius of this one. So whenever you have an outer radius and an inner radius, it's always the inner radius is always the outer radius minus the distance between them, which is our thickness, which is 3 mil in this case. If this was outside, you need to add 3 mil to it. So let's constrain the radius here. It's going to be tackle box dot border radius minus tackle box dot thickness. And now we will always have 3 mils between these two, which is what we want. So let's close this, and now we can pocket this one. So pad is to extrude, pocket is to pocket basically In Fusion they are both called extrude, but here they are separate. So tackle box dot section height. Yeah, section height. Okay, there might be something wrong here, or no? This is 100, the 300. No, I think we're fine. This should be 300. We'll figure that out in a bit. Okay, actually let's go to the section width and let's decrease it to 100. And let's make this 200. Okay, now we still have this datum plane, so we can use it again. I'm gonna create a sketch here, another one. Let me remove these headsets, I don't need them anymore. It's getting hot. Okay, so again we need to define. No, I clicked on this line by mistake. Just regular triangle. Now the same thing as we did before. Let's do the thickness here first. So this is gonna be the tackle box dot thickness, but here when we're constraining the height we need to do a bit more math basically, and we need to create a fillet up here, something like that. Okay, so this is 3 mils. Now this right here we need to constrain it, so the distance between this line, this point, and this point vertically is going to be, so here what do we have? We have a thickness, then we have the length of section 1, and then another thickness. So tackle box dot thickness twice multiplied by 2 plus tackle box dot section 1 length. I keep saying height. And this should be exactly 3 mils away from this one. And now let's define the width. So I'm gonna select this line, constraint horizontal distance, and this is going to be our tackle box dot section width. And what else do we need to constrain? Now we need to add the constraint for this line basically. So if we select this point and this point, we could have selected this one, it's fine, the same. And constrain vertical distance. So what is the distance here? So the distance from this point to this point is a thickness, section 1 length, another thickness, and then section 2 length. So this is gonna be the tackle box dot thickness multiplied by 2 plus tackle box dot section 1 length plus tackle box dot section 2 length, 306. Or we can just do tackle box dot total length, which is the entire thing, minus tackle box dot thickness. It should give us the same number, yeah. So we only want 3 mils here. And we have one constraint that we haven't done yet, which is the radius basically here. And same as we did here, it's the outer radius minus the thickness. So constrain the radius. This is going to be the tackle box dot what did I call it, border radius, minus the tackle box dot thickness. and now we're fully constrained. So we close it. With the sketch selected, we are going to pocket, and the amount is going to be tacklebox dot section height. So now we can play around with these sections. Let's make it like 150. It will automatically update. Let's make it bigger. The width, let's make it 120. It will automatically update. As you can see, this is the total dimension of the box. So for example, my printer will only print 250 by 250 millimeters. So if I want to print this tackle box, I want to make sure that the total amount here is less than 250. So the total length, for example, here will not work. I need to make these smaller. Let's say section 2, let's make it 130, or let's make it 140, and then this one, let's make it 90. Then, for example, this is fine for my Bambu Lab printer. Okay, so we made the two sections, we made them configurable. We can make this one bigger or smaller or wider or deeper. We still need to do the rig holder. This is going to be a bit tricky. Let me save just in case. So desktop, FreeCAD. Let's call this tackle box. Copy. Oh, okay, tackle box, yeah, save. Okay, now for the rig holder. So I have another spreadsheet for the rig holder. We only define the width here. We might need to define the depth. Okay, so for rig holders, we have two sections for the rig holder. Usually we have the section where you put your hooks, and then we have the section where it has foam. I don't know if they are the same depth. Interesting. I don't know, to be honest. But this section, it has a length, and then there's a separator between them. So we need to model that. And let's assume they have the same depth. Samer, hi there, hi. So yeah, let's assume they have the same depth. Where was FreeCAD? Here. Let's just call it depth. And I'm gonna do it at 25. No, maybe more. 30. We can change it, it's fine. And then let's do the hook area. So the hook area is this section right here. Let's give this a length. If we give this a length, and we know the thickness here, so we can calculate this length basically. So the hook area, let's say it's I'm just gonna throw a number, 60. Okay, so we can start with that tackle box. So again, with this datum plane, we're gonna reuse it. Create a sketch, and let's create a rectangle here. Add a fillet to this side, and let's start defining some values. So between this point and this point, we can define the horizontal distance to be the total length minus the thickness, or the total width minus the thickness. So this is going to be tacklebox.total width interesting. Total property not found. Okay, I'm not sure why it's not showing any suggestions. Huh. But it's working. I don't know. And the same here, it's the total length minus the thickness. So this point and this point, we can do that. So tackle box. What's the difference between these two? Anyways, total length minus the tackle box dot thickness. Okay, and let's define this radius here. So I'm gonna click this arc, constraint radius, and this is going to be the tackle box dot border radius. I'm not sure why it's not showing suggestions anymore, but fine, I guess. Thickness. Okay, we need to define this line. So this is going to be, if I select this point and the origin, I can constrain the horizontal distance. Whoops. Okay, so the distance here is going to be, did we define the width? Yeah, we have the, no, not the tackle box. What was it? Rig holder. What's happening with FreeCAD? Okay, let me restart FreeCAD. So do you guys have any questions so far? I hope it's obvious, but we're making a tackle box for fishing. Okay, so back at it, yeah. So we can actually, we don't have to constrain this way. We can just click this line, constrain the vertical distance, and this is going to be the rig holder dot width. This should automatically be 3 mils. And we need the height of this section. If we click this line, this is going to be the rig holder dot length. What was it? Height? No. Oh, come on, what did I call it? Rig holder. Oh, okay. This is the length. It's hook area length. So again, this is gonna be our rig holder dot hook area length. Okay, that's it. Now it's green, fully constrained, close, and we can select the sketch. Should be in part design, and now we can pocket. And here the value is tackle box dot section height. So yeah, FreeCAD does have its issues. Like for example, right now it's not showing me any suggestions for some reason. I don't know if I clicked anything wrong. Oh wait, no. No. This is not the tackle box dot section height. This is the rig holder dot depth. Yeah. So the depth here, it's 30, 70, 60, okay. And now we need to create this cutout right here for the foam. Now I'm not sure if the foam section needs its own depth. Again, I think it's fine, because if you get like a foam that is like 50 mil deep, for example, you can just change this to 50. I don't know why you would need a bigger one unless you have like a really big boilies and you want them to fit here. Yeah, let's make it different. So let's say the foam area depth. Let's make it different. Let's here, for example, make it 60. Now we need to, yeah, that's the datum plane. So now we need to create another sketch. There is some repetition here, but at least we're gonna have like a fully parametric design. So sometimes you do have to repeat some stuff. So let's start by defining this point. Here it's going to be our tackle box dot total width minus tackle box dot thickness. And let's define the radius. It's going to be tackle box dot border radius minus tackle box dot thickness. Why isn't it showing the suggestions? Okay, and the vertical distance between this line and this point is the thickness. Okay, what else? We have the width, we already know it. It's the rig holder dot width. And we're left with the height. So the height or the length is gonna be, we can do something. Let's select this point and this point. So we know the total length. If we remove from it this thickness and the length of this area, which we already know, and another thickness, so two thicknesses, then we're gonna get the exact height. So this is gonna be the tackle box dot total, I keep saying height, it's length. This is gonna be the thickness multiplied by 2. We need to remove two thicknesses, and then we need to remove the rig holder dot hook area length, which is the length of this one. And now we're fully constrained. And now I can add this by rig holder dot foam area depth. Now I think ideally the foam area depth should be something like you give it the thickness of the foam and then it will automatically calculate the depth, but I think this will be fine for now. Okay, what else? Now I don't think this is how it looks. This section right here, maybe this should be lower. Let me see, where is it? Or is it fine? Yeah, I think it should be lower. So let's lower this down a bit. But how lower? If we define this right here, then we can use the same value for this one. So this is the rig or the hook holder. So let's do it now. So the rig holder here, let's do let's call it hook holder. Yeah, we can go to the spreadsheet, make it fancy. We can merge two cells, make it bold and centered. Back to part design. So for the hook holder, it's basically usually like a cylinder with some ridges on it, and we can just drop it in place. So we can model these two things. Yeah, let's do that. So we need the diameter of this cylinder, maybe some tolerance, and we need to know how far down it will go. So we'll call that an offset. Let's do that. So hook holder diameter, let's call this hook holder offset. Do we need anything else? We can do these, we can get these from the thickness. Yeah, I think this should be fine. Now in terms of tolerance, I will add it to the main file, the tackle box. Let's do it here. Tolerance, let's do 0.2. It's usually enough. So for the diameter, I don't know, 8. No, that's an alias. 8. Offset, let's do 10. And we need to give them an alias, so offset. Okay. Oh wait, we need more parameters. So offset from top, and we need, this is also called top. Let's call this Y offset and Z offset. Okay, so hook holder, this is the Z offset. And let's also update the alias. And then this one is gonna be the Y offset. And let's do 25, no 20. Y offset is here. Now here I would add minimum and maximum values for sure, especially for these, because you don't want someone to give it like a 2 mil 5 offset, and then it has, or 2 mil Y offset, and then it has a diameter of 10, so it's gonna, you're gonna have a cylinder like right here. We want it somewhere here in the middle between these two, and we want enough space to like put it in place. We need clearance, but yeah. So we need to model a cylinder here. This is fairly easy. We can either like do a sketch here and extrude it, but we also need to keep in mind that we need some offset, some tolerance. So 0.2 millimeter from this side and 0.2 millimeter from this side. So what we can do, I think, is we cannot, okay, this needs to be its own body, because here's the thing. If I add a cylinder now, attach it, let's say, to this plane. Okay. Let's for now just give it like a 30 mil height and the diameter of 5. I'm just doing this to show you. So in the Y direction, oh, not Y direction, this is 0. In the X direction, okay. Oh wait, no, yeah, we need to, come on, where are you? In the Y direction, let's lift it up. Okay, so let's assume that we're adding a cylinder here. We cannot do that, so I'm surprised it didn't show an error. Now we cannot see the cylinder, of course, but usually it shows an error. I don't know why it didn't. But in part design, in the same body, you cannot have two solid bodies. So if we're trying to add a cylinder here in mid-air, then this will create two bodies that are not attached, and you cannot do that in part design. You can do that in other workbenches, but not in part design. You cannot do that. Each body should have a single solid body, basically. So we need to create a new body, and let's move this body to here, to the center of this, basically where we want to place the cylinder, right in the center. And to do that, we can, with the body selected, we can go to the data tab down here, and we can move it. We can move it in the Z axis. So we want to lift it up by how much? By the tackle box dot total height minus the rig holder dot offset, was it? Rig holder hook holder Z offset. Yeah, so this is where the cylinder will be in terms of like the Z height. It's gonna be like that. And now we want to move it on the X and Y to be exactly here in the middle. So how are we gonna do that? In the Y axis, actually in the Y axis we don't want it in the middle because we have an Y offset that we can control. So this should be similar to what we did, which is tackle box dot total length minus rig holder Y offset. Something is wrong. Yeah. Okay, and now in terms of X, the body selected, again, click the formula editor. This is going to be our tackle box dot total width minus, so if we remove the thickness, we'll end up at this line, and we want to move half the width of the rig holder. So we remove the tackle box dot thickness first, then not spreadsheet, rig holder dot width divided by 2, and now we should be where we want. Now, is this an offset of 20? What will 30 look like? Interesting. Oh, the length is 50, so 25 should be in the center, right? Okay, 25 will be in the center, but we have a thickness, so I'm gonna change this. We need to remove the tackle box dot, oh come on, dot thickness first, and then I'm gonna remove the rig hook Y offset. Okay, so now this is 50. If I remove 25, it's gonna be exactly in the center. This is what we want. So now this is where our body is, and we can, let me show the origin again. We can attach a cylinder to the YZ plane. If we do that, additive cylinder, and attach it to the YZ plane. Interesting. It is in the center this way, which is good. This is what we want. But now we need to move it. We need to move it. So rig holder dot what was it called? Hook holder diameter. So this is the radius, so we're gonna divide it by 2 because it's the radius. We define the diameter. Now the height. The height is gonna be, we already know the width from here to here, right? But oh, what did I do? No. Delete this. Yeah. Okay, let's not click on edges. Will it happen again if I click on an edge? Okay. But I didn't click this to select. It's weird. As you can see, FreeCAD has some bugs, but it's manageable. So we already know the total width between this line and this line, and we want a bit of tolerance, which is, we defined it. Oh my god, it crashed. Please tell me it's gonna recover the file. You know, FreeCAD crashed on me only twice, and these 2 times I was live streaming. It's impressive. Only when I'm live streaming. Nice. Okay, so we didn't lose much. Let me save just in case. To redo this, so tackle box dot total length minus tackle box dot thickness minus rig holder dot Z offset. And again, tackle box dot total width minus, oh come on, tackle box dot thickness minus rig holder dot so we're doing the x. The x, we need to remove the thickness and then the width divided by 2. Is it right? No, it's not right, because the y is wrong. It's the y offset. Yeah. Now if I go to the rig holder, I can make this 25, and it should be, no, this is the Z offset reverted. This is the 1. Hook area 50, the offset is 25. It should be in the middle. It is. Okay, great. Now I'm gonna toggle this as an active body, because when it crashed, it's not the active body anymore. We are going to create an additive cylinder. We're gonna attach it to the XZ plane, and then looking from the top, should be on the center on all the axes except for this one. That's fine. Again, the radius is going to be our rig holder diameter divided by 2. The height is going to be, so the height is going to be our rig holder dot width, which gives us the entire width, but we need to remove from it the tackle box dot tolerance, but we want to remove tolerance on each side, so I'm gonna multiply by 2. Now if you notice, it's not centered, but we will fix that. So let me copy this. This is the entire length of this cylinder, so I want to move it this way by half that amount, then it's gonna be centered. And this way is, which way? Not this way, no. It's the Y, no. It's the Z direction, because, oh, it's in the negative Z direction. So I want to do minus, and then I'm gonna put some brackets. This is our total height, and then divided by 2. And now we're gonna have 0.2 mil here and 0.2 mil here, but we have a problem. Let's not overcomplicate it at the moment. I don't want to add minimums and maximum values. I'm just gonna come here, assume this is 28 or something, because it's already an hour in and we are not done yet. So let's do the ridges, because I want to show you how you can do arrays in Blender, not Blender, it's FreeCAD. So to do this ridge, we can do a simple, we can do a simple cylinder that is slightly bigger than this one. Let's say 1 mil or even less, 0.5 mil bigger. Let's try it. So I'm gonna create a cylinder, attach it to this plane again, and let's do so that one was rig holder dot diameter divided by 2. So let's take the entire diameter and let's add 0.5 mil to it and then divide it by 2. Okay. And the height, should we make it 1 mil? Maybe this we can make it also 1 mil. This should be fine. Okay, and I want to move it all the way up here, and to do that we need to do minus. Do I still have it copied? Yeah, divided by 2. Basically the same thing we did for the other one, and then click OK. So now we need to repeat this multiple times. And how do we do that? Let me hide the origin. So there are multiple ways. I can just click, select the command that we did at the end, and then do a linear pattern. And here we can, let's see, reverse direction. No, it was the correct direction. Yeah. So as you can see, it's trying to add it, but it's too far because the length here is, so we needed to go from this place to this place, and we already have this copied right here. It's the width minus 2 tolerances. This is the total length. Where did it go? Yeah, it's now, no, actually I think we need to remove also the 1 mil from it. So -1, yeah, now it's fine. And now we can play around with this, like make it 10, 20, whatever. We can actually, let's do that here. Number of ridges. Let's say 20 or 12. And then here, this is gonna be the rig holder dot number of ridges. Okay. So now I can change this to 16 and it will update. Nice. Okay, so this is one way of doing it. Now for linear patterns, it's fine. You can just do that. For more complex designs, maybe in the next episode, next Monday, we can work with with the linear arrays in lattice 2 or even polar arrays, these have way more settings than this one. But this one is fine for now, the regular linear pattern. Okay, now we need to drop this down to the same level, because at the moment we cannot put anything here. It's gonna go like up and then down. Should be fairly simple. We need to go back to the box, make it active, then click, we don't need to show it, just select the datum plane, and let's create a sketch, just a basic rectangle here. Okay, and let's do the good old boring constraints. This is going to be the tackle box dot total width minus the tackle box dot thickness, and we need to define the vertical constraint. So from here to here, this is going to be tackle box dot thickness plus tackle box dot, oh no, we don't actually know this value, we know this value up here. So let's define the value from this point to this point. This one we know, because we know the total height and we know the length of this one. This one is auto calculated. So it's going to be the tackle box dot total length, I keep saying height again, minus tackle box dot thickness minus rig holder dot hook area length. So thickness minus hook area length. Okay, this should be right on that line. Yeah, brilliant. And now we know the width of this. This is easy. This is the rig holder dot width. Okay, so all we need to do is just say that this line is equal to the thickness, and this is tackle box dot thickness, and now we're fully constrained. Close, and we need to drop this by the Z offset that we applied to this cylinder. So this is going to be the rig holder dot Z offset, hook holder Z offset, and now we can pass the line over it. Okay, but we're missing something. So how are we gonna insert this here in place? So they have in the original, like if you buy a pre-made one, they have these. I guess we can model them. Should be just like a box coming up here and then an opening for it to drop into. Let's do that. Let's start first by drawing the box, or drawing the two boxes, and then we can extrude them down. Let's see. So we select this datum plane again. We need one box here and one box here. Let's do one, and then we can do like the equal commands on the other one. I'm thinking maybe a center point would... Okay, so if you already made a box and you want it to be a center rectangle, not a regular rectangle, you can just get any point. And now you can select this point and this point and this point and make them symmetric. Now you have a center point rectangle. So because the center point rectangle is going to be easier to put in place because we already placed this one on that line. So let's get this and this and constrain the vertical distance. So what is the vertical distance here? It is the tackle box total length minus tackle box dot thickness minus, so we're here at the moment and we need to remove the y offset, right? The rig holder dot y offset, and now we should be exactly in the middle of this, so we cannot move up and down. This is what we want. And now we can do the same here. I'm gonna just put a point here, click this, this, and the point, make them symmetric, and then this point and this point can be constrained horizontally, so they are on the same horizontal line. So this now cannot move up and down. Okay, and we want this line to be exactly here, so let's do that. So from here to here, the horizontal distance is going to be the tackle box thickness multiplied by 2 plus tackle box dot section width, was it? Yeah. Now we're on this line and let's do the height. So what is the height here? The height is going to be, we know the diameter and we added 1 mil to it, so we have rig holder dot diameter plus 1 mil. Now it should be exactly the same, right? But we want to add some thickness. Let me see it again. Yeah, we need to add thickness from the top and thickness from the bottom, so 2 times thickness. So plus tackle box dot thickness multiplied by 2. So you guys don't have any questions? No one is sending anything in the chat. Anyways, so the length of this, how much do we want to make it? Maybe we can put it here. So hook holder, what do we need to call this? Rest. Let's say it's 12 mils. No, this is the alias. The contents is 12 mil. And now we can do rig holder dot rest length. Okay, now let's do this one. So first of all, this and this should be equal, and then this and this should be equal, and now we just need to put this one here, which is super easy. Just gonna click this and this, and it is the total width Oh, come on. Total width minus the tackle box dot thickness. Okay, let's close it. And now we're gonna pad this. Interesting. It's reversed. Yeah, it's reversed. I was trying to pad it upwards, which will create two bodies, and as you know, our design, it doesn't love two bodies. So how much do we want to go down? We already know that it is the rig holder dot depth. So this will go all the way down. Now we need to cut out basically where this one will go. So let's click OK. And I'm thinking about something. What if we cut it out in a way that also has the ridges? Then this will secure it in place even more. This is fun. This is gonna be fun. Yeah, let's do that. Let's do that. So we can actually go back to the pad. We could have done it in the same sketch. Why did I do that? Anyways, it's fine. Let's just create a new sketch. Cancel with the datum plane selected. I'm gonna create a sketch. A centered rectangle. Can just do this. Okay. So this point right here and this point right there. This is going to be equal to our tackle box dot total length minus the tackle box dot thickness. So total length minus thickness minus we called it the offset, right? We called it y offset, which is offset from the top on the y-axis. Yeah, exactly. So this is here, and we need to define the middle point. So this is the horizontal distance, and the horizontal distance is going to be our total width minus the thickness minus the rig holder dot width divided by 2. So this width divided by 2, and now we're dead center. And now the height or the width of this, let's start with the width. This is easy, it's just the rig holder dot width. That's it. And now the height is going to be the rig holder. We have a diameter, but I need to add some tolerance. So the tolerance, we get it from the tackle box dot tolerance multiplied by 2. I want tolerance from both sides. What's wrong? Oh, this is not the rig holder, it's the tackle box. Yeah. Okay, so you see 0.2 from this side and 0.2 from this side. We'll deal with the ridges later. Click close, and now we can pad this down by how much? Okay, so we have the rig holder dot z offset basically, but this will go to the center of this, you see, center of the cylinder. We need to go down by we need to add to this the rig holder dot diameter divided by 2 because we want a radius, and now it's gonna go all the way, but we need to add also some tolerance to this, so plus tackle box dot tolerance. And look at this now. If I go here, for example, okay, wait, sorry, yeah, if I go to the rig holder and I change the Y offset, let's say to 30, it's gonna move down. Let's change it to wait, Y offset, let's just make it 10. Everything is gonna move up. Now, yeah, this is gonna look weird, I know. We need to add like minimum and maximum values, but yeah, everything will move with it. It's amazing. Okay, so now let's add cutouts for these ridges, and maybe we need to make this smaller. Let's just do like 2, maybe a 2.5 ridges. So where is this? 8 mil. Yeah, 8 should be fine. Okay, back to the boring math. So here I'm gonna do one of them, and then we should be able to do the same thing we did before, which is the linear pattern. So let's do a center rectangle again. Okay, back to the boring math. So from the origin, if we go horizontally, is going to be, oh wait, let's do the vertical first. So vertically, it's going to be the tackle box dot total length minus tackle box dot thickness minus rig holder dot Y offset. Okay, so now we can only move this way right here. So how much do we need? So we need this, because this is already one tolerance away from here, right? So we can actually put this line right here. This will make it easier. So from this point to this point, horizontally is going to be the tackle box dot thickness multiplied by 2 plus the tackle box dot section width. And let me save, because FreeCAD is gonna crash on me like always. Always on a live stream. It doesn't crash when I'm not on a live stream. It's very weird. Okay. So now we can only go this way because we still haven't defined the width. And the width is, did we define a ridge's width? No, we made it constant. 1 mil, I think it was 1 mil. So this is 1 mil plus tackle box dot what was it? Tolerance. I wrote it so much that I forgot it. And this is tackle box dot tolerance multiplied by 2. Maybe we need to make this 1 mil also a parameter, I don't know. We'll see. And this one right here, the height. The height is going to be our rig holder dot diameter. Was it +1 or +2? Huh. Something is wrong. Oh wait, no. Okay, let's say +1 plus, we'll check it in a bit, tackle box dot tolerance multiplied by 2. Need to add some tolerance. Okay, close. And now we need to pocket this down. How much do we need to pocket? Again, it's going to be our rig holder.z offset plus or rig holder.diameter divided by 2, the radius, plus let's add 1 tolerance. Okay, if we look at it from the top, this is exactly 0.2 mil from all sides. Okay, now we need to repeat this along this section. So clicking OK, if I click that, and now we do a linear pattern. So where is it? First of all, we need to define the width, which is, let's assume it's the rig holder width for now. We will fine tune it. Okay, it's not the rig holder width, so we need to so I remember we did rig holder width -1 on the other one, -1, but I think here we need to also remove the tolerance, so we need to remove the tackle box dot tolerance. What is it, multiplied by 2? Yeah, that's it. That is it. And now the length, or sorry, not the length, the occurrence is going to be our rig holder dot number of ridges, and just like that, it's magic. So now I can come here, I can change the number of ridges to 20, and now look at that. And I can also change the length, let's say to 12. And this is not going anywhere when you put it here. So let's get these back to 8. Let's make this, was it 12? I think these are enough. Okay. So now we have one part of the tackle box. We still need the lid, but I don't think I'm gonna do the lid in this live stream because it's already 11 p.m. So maybe on next Monday we can do the lid. Now, if you guys have any ideas for projects like this one, anything fishing related, or if it wasn't fishing related, I think it's fine. We have a Discord server where we share project ideas. You can join and share your ideas, and maybe we can do them in a live stream. So do you guys have any questions about what we did today? Or any questions on FreeCAD or CAD in general? I'm actually excited for this. I might use it. I have a rig holder, but yeah, I don't have one like that has sockets and sections and stuff. We can even print something maybe that fits inside of here that has even more sections. Yeah, like imagine 3 sections here, and then like 2 or 3 sections here that go this way. This could be sick. So you guys have no questions? Well, then I guess that's it. Again, don't forget to join the Discord server. It's just not just about CAD. We also talk about fishing stuff, lure fishing, course fishing, and some other projects. So yeah, that's it. Thank you guys for watching, and see you in the next live stream. The next live stream will be on Friday. We're gonna do a lure, so we're doing a lure every Friday, and we're doing some CAD work every Monday. So yeah, see you in the next stream. Bye.